Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, GIMS Management Technical Campus, Greater Noida. The subject that I teach in this semester for BTech 5th semester students of ECE branch is digital communication, and the topic that I discussed today in this video lecture is Coherent M array schemes, MSK and GMSK, or you may say Gaussian MSK. MSK means minimum shift keying. Okay. Now, M array signal schemes. If in previous video lecture, we focused on QPSK. In QPSK, 2 bits are combined to get a symbol. So you can say that this is QPSK is a 2 array signal scheme, because in QPSK you have to combine 2 bits, isn't it? But if you further move with the from this QPSK, there is also a possibility of combining more than 2 bits to get a symbol, right? So M array signal schemes is like that. So in this signaling scheme, 2 or more bits are grouped together to form a symbol. Means if you combine more than 2 bits, you get a symbol. For example, if you combine 3 bits, then 3 bits, then you get a symbol of 3 bits, and so on. So one of the M possible signals, for example, in QPSK, when you combined 2 bits to get a symbol, then 4 symbols are possible, and each symbol has its own equation to show. Similarly, if you combined more than 2 bits, again you have M possible signals: S1T, S2T, S3T, S4T up to SMT. And in QPSK case, QPSK case is a case where you have a just like a 2 array signaling schemes where you have to combine 2 bits to get the symbols. So in QPSK case, we have 4 types of equations. One equation represents 0, 0, second equation represents 0, 1, third equation represents 1, 0, and fourth equation represents 1, 1. So if you combine 3 bits, you get a symbol, then you have a more number of equation that you have that represent the signals, or you may say mathematical model of each symbol that you have. So how you know that how many signals that you get after combined 2 or more than 2 bits? It's a general mathematical formula. For example, in the case of QPSK, where n is equals to 2, so 2 to the power 2 is equals to m. So you have m possible signals. So the number of possible signals in general is m is equals to 2 to the power n, where n is an integer. It depends upon how many bits you want to combine to get the signal, right? So n represent that. So in QPSK, n is equals to 2, so you get 2 to the power 2 is equals to 4. So 4 possible signal that you see in the case of in case of QPSK. So this is the basic concept that involved in coherent M array schemes. So the symbol value of m for a given value of n. So if n, look at this, if n is equals to 1, you get 2 symbols, you get 2 signals, and this is the case of, for example, PSK. In PSK, you have 2 equations that one equation represents 0 degree and another represent 180 degree phase shift. So in similar way, when n is equals to 2, then you have n is equals to, and how you get this n is equals to 2? When you combine 2 bits, when you combine 2 bits, this is the 4 possible ways that you get to form a symbol. And how many number of signals that we have? 4. So if you combine 3 bits, then this is the possibility. And total number is 8. So we have 8 possible signals that represent each symbol that have 3 number of bits, right? So, and so on. And it goes to 4. And this is the possible ways, and the 16 signal that you get that represent the equations with respect to each particular combinations of bit, right? And not only that, you have 16 symbols. In case of n is equals to 3, you get 8 symbols. 8 symbols, 8 equations. N is equals to 2, you have 4 symbols, 4 equations. And n is equals to 1, you have obviously 2 symbols, 2 equations, right? Now, depending on the variation of amplitude, phase, or frequency of the carrier, the modulation scheme is called M-ary ASK, M-ary PSK, and M-ary FSK. Actually, it depends, after you combine the number of bits, right, 2 or 3 or 4, now you decided what you want actually, which parameter of the carrier that you want to change according to the combination of bits that you have, right? For example, if you combine 2 bits, so you have 4 possible symbols, 0, 0, 0, 1, 1, 0, 1, 1. Now what you want? If you want that, according to each symbol, if you want to change the phase of the carrier, then this is called QPSK, or you may say, it's a 2-ary PSK. Not only that, if you decide that you want to change amplitude, so this is also be done according to 0, 0, 0, 1, 1, 0, 1, 1. You can also change the amplitude of the carrier, keeping frequency and phase constant. So that is called M-ary ASK, right? Third possibility is that according to the number of bits that you combine to have a symbol, then the carrier is changed according to the symbol. But this time, if you want to change frequency and keeping phase and amplitude constant, then that particular modulation scheme is come in the category of M-ary FSK. M is decided from how many bits that you want to combine to get the symbols, right? So, so if you look this particular figure, that you can easily see that this particular case is the case of M-ary ASK, where the amplitude is changed and the frequency and phase remain the same, and it depends upon 1 and 0. So if you have a 1, there is a presence of signal. If there is 0, there is an absence of signal, and that come in the category. So this category of M-ary ASK. And this is your binary data. 1, 1. So this is the binary data in the form 1, 1, 0, 1, 0, 0. So this is the case of M-ary ASK. Look at this second one. Here, this is the case of M-ary PSK. Here, the frequency and amplitude remain the same, but the phase is changed every time there is a transition, right? Look at this. Here the phase change, here the phase change, here the phase change, here the phase change, and here the phase change. So that is come in the category of M-ary PSK. Look at the third figure. This particular figure, this part is shown that amplitude remains the same, phase remains the same, but the frequency is changed. So whenever 0 come in the picture, according to 0, there is this particular signal which is called as a carrier, change its frequency. So the number of cycles is minimum when 0 come in the picture, and when 1 come in the picture, then frequency change and it is high, right? So say low and high, low and high. Low frequency come when 0 is come, high frequency come in carrier when 1 is come, right? So in that way, this third picture, third signal represent M-ary FSK. So first picture is the case of M-ary ASK, second one M-ary PSK, and third one M-ary FSK. So these are the schemes that come under the category of coherent M-ary schemes, where M is decided from the number of bits that you combine to get a symbol, right? Now the word binary represent 2 bits. M represent a digit that corresponding to the number of conditions, labels or combination possible for a given number of binary variables. We already discussed that point. This is the type of digital modulation techniques used for data transmission in which instead of 1 bit, 2 or more bits are transmitted at a time as a signal as a single signal is used for multiply bit transmission. The channel bandwidth is reduced. Well, if you want to utilize minimum bandwidth, then your motto is to what you want actually, you want to combine more and more number of bits. So the number of bits required to send the signal is minimum, so the bandwidth is also required to minimum, and channel capacity is more, so you have to send more information within the available bandwidths. So M-array equations, if the digital signal is given under 4 conditions, as in the case of QPSK, such a voltage levels, frequency, phases, amplitude, then M is equals to 4. So this is the case of QPSK. So you have possible 4 equations, right? So the number of equation is 2 to the power n, where n is the number of bits that you want to combine. If you combine 3 bits at 2 to the power 3, it's 8. So 8 is the possible equation that is come after the modulation of that right 4 array scheme. So the number of bits necessary to produce a given number of condition is expressed mathematically as n is equals to log to the base 2 m, where n is the number of bits necessary, m is the number of conditions, label or combination possible with n bits. The above equation can be rearranged 2 to the power n is equals to 1. This is also we will discuss that particular equation in previous slides. 2 to the power n is equals to 1, right? For example, with 2 bits, 2 to the power 2 is equals to 4. 4 conditions are possible, or you will say 4 equations are possible, right? So in general, multi-level M-array modulation techniques are used in digital communication, as a digital inputs and with more than 2 modulation levels are allowed to transmit transmitters input. Hence, these techniques are bandwidth efficient, obviously. So there are many M-array modulation techniques. Some of these techniques modulate one parameter of the carrier signal, such as amplitude, phase, and frequency. We already discussed in previous slide this particular concept. Now come to another topic: minimum shift key. Minimum. Actually, sometimes you want to shift the frequency. You want to change in frequency minimum as possible. So when the frequency of the separation become lowest, it is known as minimum shift keying. So in digital modulation, minimum shift keying MSK is a type of continuous phase frequency shift keying that was developed in the late 1950s and 1960s. So similar to QPSK, offset quadrature phase shift keying, MSK is encoded with bits alternating between quadrature component with the Q component delayed by half the symbol period. So minimum shift keying MSK is a form of frequency modulation based on a system called continuous phase frequency shift keying. Look at the reason for minimum shift keying MSK. So it is found that binary data consisting of sharp transition between 1 and 0 states and vice versa potentially create signals that have sideband extending out a long way from the carrier, and this creates problem for many radio communication system. So as any sidebands outside the allowed bandwidth cause interference to adjacent channels and any radio communication links that may be using them. So sometimes what we see that a particular the carrier shifts its bandwidth, or you must say shift its bandwidth, and the shift of bandwidth is reached to the neighbor pulse, and that creates a problem. So it is I once again repeat that particular sentence. So if it is found that the binary data consists of sharp transition between 1 and 0 state and vice versa potentially creates signals that have sideband extending out a long way from the carrier. So MSK, minimum shift keying, has the feature that there are no phase discontinuities. So first condition is that There is no phase discontinuity in that, and this significantly reduces the bandwidth needed over other form of phase and frequency shift keying. So minimum shift keying, when looking at a plot of signal using MSK modulation, it can be seen that the modulation data signal changes the frequency of the signal and there are no phase discontinuities. This arises as a result of unique factor of MSK, that the frequency difference between the logical 1 and logical 0 state is always equal to half the data rate. This can be expressed in terms of the modulation index and it is always equal to 0.5. So in this particular picture, if you see that there is a little bit change in frequency, say minimum shift in the frequency, phase, and there is a continuity also there in the phase. There is no phase change. But whenever there is a transition of 1 to 0 or 0 to 1, look at the frequency. Frequency is changed little, minimum frequency is to be changed. And that is why this is called minimum shift keying signals. There is a minimum shift in the frequency of the signal while phase remains a constant. So this is a minimum shift keying case. Come to the Gaussian MSK. It is similar to MSK but a little bit of change. So Gaussian minimum shift keying, or to give its full title, Gaussian filtered minimum shift keying. This is the full form of that. So GMSK is a form of frequency modulation that is used in radio communication system like MSK. So GMSK is probably most widely associated with the 2G GSM mobile communication system, where it provides to be an effective form of modulation. So it was one of the reasons that GSM cell phones had a long battery life in view of the high efficiency that could be obtained from the RF power amplifiers. So GMSK modulation is based on MSK, which itself a form of continuous phase frequency shift keying. So one of the problem with the standard form of PSK is the sidebands extended out of the carrier. To overcome this, MSK and its derivative GMSK can be used. So a special form of MSK is GMSK. You have an input data, then Gaussian low pass filter. So in GMSK, Gaussian low pass filter is used. That's why this MSK scheme is called GMSK, or Gaussian minimum shift keying. And we have voltage controlled oscillator, then RF amplifiers. So GMSK modulation are what is known as continuous phase scheme. Here there are no phase discontinuities because of frequency change occur at the carrier zero crossing points. So this arises as a result of the unique factor of MSK, that the frequency difference between the logical 1 and logical 0 states is always equal to half the data rate. This can be expressed in terms of the modulation index, and it is always equal to 0.5. So there are again certain points about GMSK. First one is the plot of the spectrum of an MSK signal shows sidebands extending well beyond a bandwidth equal to the data rate. Second point, this can be reduced by passing the modulating signal through a low pass filter prior to applying it to the carrier. Third, the requirement for the filter are that it should have a sharp cutoff, narrow bandwidth, and its impulse response should show no overshoot. And last point, the ideal filter is known as Gaussian filter, which has a Gaussian shaped response to an impulse and no ringing. In this way, the basic MSK signal converted to GMSK modulation by using this Gaussian filter. So thank you very much.